Hello everyone, in this video we'll talk about the mobile IP and how to handle mobility in the cellular networks. Okay, so mobile IP is a standard designed to handle the mobility in the IP networks. So for example, if in the campus we deploy a lot of wireless access points, and then we want to enable mobility, let's say a user having a session call session through the access points, like or video call sessions. When it moves to, and then changing the access points, then the video call session can be maintained. So this is the purpose of the mobile IP. Okay, so the standard is written in the RFC 3344, and then it has many features that we already seen, like home agents, foreign agents, care of address, encapsulations. Okay, so we haven't discussed about encapsulation but then we'll talk about this later. Okay, and then there are three components or three mechanisms that are included in the standard. The first one, indirect routing, agent discovery, and registration. So basically we already discussed the first part and the second part, but then we will add this agent discovery. Okay, we'll again go a bit more technical in this mobile IP sections. Okay, so the indirect routing in the mobile IP, as we already discussed before, the correspondent will first send the packet to by using the permanent address of the mobile agent. Okay, and then this packet is intercepted by the home agent, and then the home agent will check the current location of this mobile agent. So then it knows that, okay, now it is located at the foreign networks with this let's say care of address 79 and so on and blah blah blah. So the home agent will forward this packet from the correspondent by encapsulating this packet within a new IP or datagram packet. Alright, so basically now the new packet will have the destination IP address of the care of address. Okay, so and also this care of address is actually the address of the router or of the foreign agent in the visiting network. Okay, now when this packet arrives at the foreign agent, this packet will be decapsulated. So the foreign agent will find that there is a new packet where the destination address is the permanent address of the mobile agent. So the foreign agent will forward this to the mobile agent. Okay, so actually until up to this we have the same and I mean after this when the mobile agent wants to send a reply back to the correspondent, then we can have the same mechanism as before. The only thing that we haven't discussed before is that there is this encapsulation mechanism by the home agent when it's forwarding the packet from correspondent to the foreign agent. Alright, and then the second one is the agent discovery. So there is this advertisement sent by the home agent or the foreign agent to the mobile terminals within the networks. So this advertisement is sent by broadcasting ICMP messages, and it contains some information like, for example, this bits indicating whether it is a home or a foreign agent and whether registration is correct or not. Okay, so this is the complete flow of registration, starting from the agent discovery or agent advertisements. So first of all, let's say now the case is when the mobile agent is going to or it's arriving to the visited networks. All right, and then the foreign agent will send a broadcast message about the agent advertisements, and it contains the care of address or the IP address of this foreign agent. And somehow the mobile agent receives this advertisement message from the foreign agent, and let's say it also requires to register upon receiving it. So mobile agent will send a registration request to the foreign agent stating about this its permanent address and the home agent address. Alright, so after that, the foreign agent will forward this registration request to the home agent, consisting of the care of address, and then also the address of the permanent address of the mobile agent. So at the end of this process, the home agent will bind the care of address with the permanent address of the mobile agents. And then after that, the home agent will send the reply of this registration to the foreign agent, and finally the foreign agent will send the registration reply to the mobile agent. So this is the end of the registration when, let's say, the mobile agent enters the new visited networks. Okay, now so let's move on to the cellular networks, and let's recall the cellular network architecture. So let's say we have several MSCs and telco providers or network providers, and each MSC will be responsible for several base stations. Alright, so now we will use the same terminologies we used in the mobile IP and the principle of mobility before. So in the home network, in the cellular networks, is basically a network of cellular provider that we subscribe to. Yeah, it depends on our telco providers, and also it can be related with the MSC where we when we first register our, let's say, SIM cards. Let's say now we're connected to this base station, and the base station is connected to this MSC, so this MSC becomes our home networks. So right now, in the home network, there is an entity called the Home Location Register, or HLR. This HLR is basically a database containing permanent cell phone numbers, profile information, and other information, right? Including the information about the current location of this specific mobile number. So it could be within the home network itself, or it can be also in other networks. And then the second one, the visit networks. This is network in which the mobile is currently resides. It could be in, actually it could be in the same home network itself, or it could be in other networks. Okay, and again in the visitor network, there is an entity called the Visitor Location Register, or VLR. Basically, it is a database with the entry of user currently in the networks. So so basically, in each network or each MSC have these two components, the HLR and VLR. So HLR is only for the mobile user which is registered in that specific home network, while the VLR is for all the mobile users that currently resides in that MSC or in that networks. Alright, so let's discuss about the indirect routing in the mobile networks. Alright, so let's say the correspondent is, and so we'll talk about the GSM networks. Only voice traffic is considered, and the correspondent is the, let's say, a phone call from the landline telephone company, and then first it goes to the public switch telephone networks. This is not our main focus of discussion. So basically, the call will be routed to the home MSC first, and home MSC will consult the HLR to get the current location of the destination mobile user. And okay, so we have the new terminology here. We have something called roaming number. This is analogous to the care of address. So now let's say it is found out that the mobile agent is located at the visit network. So the home MSC will set up a second leg of call to the MSC in the visited networks. Alright, so the MSC in the visited networks will complete the call through the base station to the mobile. So basically, there are more processes actually to find where which base station that the mobile user is attached to. Okay, now we'll discuss a bit about the handoff. And first of all, we talk about the handoff within the common MSC. So handoff is a mechanism which is very important when the mobile user is moving from one base station to another base station. So for example, like the user now is moving in the car, and there is a call session going on at the moment, and then it's moving further away from the old base stations, and then it's going getting closer to the new base stations. So in order to avoid disruption or interruption in the call stations, so it has to go through the handoff mechanisms. And then some reasons for the handoff, let's say it's getting a stronger signal to or from new base SS. So in this case, like for example, it's getting the signal is getting stronger when it's moving towards the new base stations. Also, the reason is for the load balancing. For example, the network providers wants to balance the load of the base stations that within the same, let's say, in the same areas. So for example, like let's say there is more loads in this base station, in the left base station, than the right base stations, and then there are some users that can be covered by the two base stations. So the network operators may decide to perform handoff for several mobile users. And then I think this is most important thing. Basically, the GSM doesn't mandate why to perform handoff. So basically, the policy of handoff, it is up to the operators, but it only gives a standard about the mechanism or the how. Okay, so let's talk about the details of the handoff mechanism. And this, as we already see this in the previous slides, the handoff is initiated by the old base station, and the old base station detects that there is a mobile user where the signal is decreasing over time, so it initiates to informs the MSC for initiating the handoff. All right, because there is one specific user moving further away from the base station. So the second part, after this MSC receiving the initiation from the old base station, it will set up the path and allocate resources of the new base station, because in cellular networks, when we want to admit new users, the base station have to allocate some resource so it can be admitted. Alright, so and then after that, the new base station will allocate new radio resources, and then after the resource is ready, the new base station will inform the MSC and also the old base station that the resource is ready at the new base stations, and then the old base stations will tell the mobile users to perform handoff to the new base stations. Okay, so basically it gives the information about the ID of the new base station and so on, and then the mobile will perform signaling with the new base station to activate the new channels. Alright, and then the mobile user will also signals the new base to the MSC. So basically, after this point, the handoff is complete, and the mobile switching center MSC will reroute the traffic from the old base station to the new base station. And then lastly, the MSC will release the resource at the old base station. So basically, in this case, this is also called the soft handoff. So before the user breaks the connection with the old base station, the new base station is already prepared and is ready to receive the communication from the mobile users, and the traffic is already allocated or it's already rerouted to the new base station. And then after the traffic is being handled in the new base station, only after that the resource is released in the old base stations. So this is to avoid the disruption of the ongoing session. Alright, and then what if the handoff is happening between different MSCs. Okay. In this case, we will have something called anchor MSC. This is the first MSC in the first MSC visited during the call. Okay, so let's say now when I started the call, I'm in the MSC 1, and then I'm moving to let's say I'm in the train, and then I'm moving to several base stations still in the MSC, and then I have performed handoffs during that times. But then I reach another base station which is belong to different MSC, and then the first MSC will become my anchor MSC. Okay, so this new MSC will be added to end of the MSC chain as the mobile user moves to the new MSC. And also there is optional passive minimization step to shorten the multi-MSC chain. Like for example, this the call from the correspondent routed to the MSC. This is the anchor MSC because now the mobile user is already moving to the new MSC. So the call again is routed from the anchor MSC to the new MSC. Alright, and then again, if the mobile user moves from the second MSC to the third MSC, this is the last part. The passive minimization step can be used to minimize the number of chaining from anchor MSC to the new MSC. Alright. Right. Now in LTE, so in principle, it's the handoff process is quite similar to the 3G, from preparation to execution and completion. But then there is one thing that is a bit special in LTE. So it has this MME or mobility management entity, and this MME manages the active and idle users, because sometimes the idle users is also moving to the new location, new base station or new MSC. So to detect the location of the current location of the mobile user or user equipment, the MME will send the broadcast message, the paging message to all the E node B within the MSC, the networks. Then the E node B will try to locate the requested E node B. So that's why this handoff mechanism can also become faster in this way, because the MME already knows the location of the user equipment. Alright, so now we try. It's towards the end of the mobility. Let's try to compare different terms used in cellular network and mobile IP. So basically, there's not so much difference. We use term home system, or actually also home networks in the cellular networks. So there's not much different, and also visited network or visited system. And sometimes it also says visited networks in the cellular networks. And home agent in the mobile IP is similar to the role of home. It's not gateway, by the way. It's home MSC, and together with the home location register or HLR. The foreign agent in mobile IP is similar to the role of the visited MSC and the VLR. And then the care of address in the mobile IP is similar to the roaming number. Alright, so now the last part, how the impact of the wireless and mobility on the higher layer protocols. So basically, when we talk in logical impact, there is minimum impact should be minimum. Let's say if we use best effort service, it's there is no change in the protocols, and TCP/UDP can also run over wireless on mobile networks. But then there will be differences in the terms of the performance. Like there will be more packet loss or delay due to bit errors and handoff. Alright, and the TCP will interpret loss as congestion, so it will decrease the congestion window, and that's why there are some researchers, or I don't know if this is from the companies that creates new TCP flavor for the wireless. before we already have like TCP Reno, TCP Tahoe, and so on. There is new TCP flavor for the wireless networks. And then yeah, again, real-time traffic will suffer from the delay and also limited bandwidth for the wireless links. So that's it for the chapter 7. In summary, we discussed about the wireless links, the capacity, distance, channel environments, so basically some characteristic of the wireless links. And we talk about the IEEE 802.11 or Wi-Fi and technology in the wireless access, cellular access networks. And then in the second part we talk about the mobility, first with the principles, and then case studies in mobile IP and GSM and LTE, and then lastly the impact on the higher layer protocols. So that's it on chapter 7. See you again in the next video about